All right, CNT120, we're working on our Chapter 3. We're now to the section on IPv6 addresses. So just as a quick reminder, we talked IP4, okay? Now we're going to move on to IP6. IP6 is a 128-bit address that was developed in the mid-90s, deployed early 2000s, and we're still in the process of, I'm going to say, adopting. Most things are now capable of IPv6, but it's one of those where we haven't progressed on the full adoption everywhere. But the reason these came about is they started running out of IPv4 addresses because mathematically there's a limitation to how many IPv4 addresses there are. So IPv6 came along to try to remedy that by 128-bit address. So quite a few possible IP addresses here, with the idea of hopefully we don't have to run out or deal with this again down the road. So an IPv6 is 128 bits, usually written as a hexadecimal number, 8 blocks of hexadecimal numbers separated by colons, and each one is actually 16 bits long. So if you look at the number of blocks times 16, that's where you come up with your 128 bits. Here'd be a sample IPv6 address, the whole thing. Big, long hexadecimal number. Hence why I remind you guys, don't forget about your number conversions, binary as well as hexadecimal conversions. Don't forget about those. IPv6 address, leading zeros in a 4-character hex block can be eliminated down here. So as I start having 0B80, I can drop that. 00D3, I can drop that. Okay. If a block contains all zeros, they can be written as a double colon. So here we have a series of a bunch of double zero or a bunch of zeros. I can abbreviate that by putting a double colon and saying, hey, these blocks in here were all zeros. We're eliminating that. I can only do that one time, but if I have a big long block there, I can get rid of those. I can minimize those. So here that tries to show you 2001, blah, 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 dropping those extra zeros there, dropping the leading zeros here, dropping the leading zeros here, and I make my IPv6 address a little shorter, a little more compact to deal with. If I look at my IP address on my machine, I can pull up on a Linux or Apple machine, I can do an Ifconfig and look at the IP address. So if I take my Linux machine here and I do an Ifconfig, I can see the IPv6 address. Here he is right here. Okay, there's my IPv6 address on this machine. Here would be the IP4. Here's my Mac. And now here's my IP6 address. Okay, FE80 : blah. Okay, on my Windows machine, we'll come here. I'm going to do, if I do just plain Ifconfig, I don't always see that depending on my settings. This case, I do see it. I have my IPv4, and I also have my IPv6. There's my IP4. Here's my IP6 address right here, FE80 : blah. Okay. So there's my IPv6 on my Windows machine. And just using the plain old Ifconfig command, nothing different. Now, with some terms with IPv6 addresses. A link, sometimes called a local link, is any LAN bounded by routers, okay. An interface is a node's attachment to a link onto the network, if you will. Okay, that's my IP6 interface. Dual stacked is a term that denotes or implies that my network is configured to run both IP4 and IP6. So let me do this. I'm going to pull up my network settings on my Windows machine here. I'm going to go to my network and sharing. I'll pull up my Ethernet 3 NIC. I'm going to look at the properties on it. And I'm going to look at this IPv4 is installed and running. IP6 is installed and running. So right now, this network, this device on this network is set up to be dual stacked. That it's actually both are running so that if there's something capable, it might be able to respond to. Now, if I look a little closer, I'm going to back up here. You'll see that I have internet connectivity on IP4. IP6, I'm not getting anywhere yet. So there's some devices between me and the internet that are not capable. It might be my gateway at my business or my company. It might be further on in the network. But I don't have full connectivity on IP6 yet. That's why it's dual stack, so that IP4 is going to at least get me there. I also know that it's dual stacked. If I go back and look at my IP address, I see both IP6 and IP4 there. They're both there and running. That's what they mean by dual stack. Interface ID, the last 64 bits or 4 blocks of an IP version 6 address identifies the interface, the actual node, if you will. So if I look at here at my IP6 address, the beginning part is typically my network portion, for lack of a better term, and the last part is kind of my node portion, if you will, for lack of a better description for you. So an IP version 6 actually has some structure to it. So if I start looking, the first 64 bits is usually kind of like the network portion, and the last 64 address is the interface ID. Okay, and you see up here, if I look at a global address, it's broken out a little bit further for you: global routing prefix, subnet ID, and then interface ID. But it's roughly the first half is kind of like the network portion. The second half would be like the host portion. If you had to equate this to what you already know, that's the description I often give people if they're trying to figure this out. There's a couple different types of IP version 6 addresses. Just like IP4, we had unicast, multicast, broadcast kind of thing. Okay, same kind of thing applies here. Unicast is a message going to one node. That's it. Just a message going to one node. Unicast. Multicast, we know that's a chunk of data going to multiple nodes, and it either could be for routing protocols and or multimedia or video conference, that kind of thing. I'll notice that I don't see broadcast. IP version 6 eliminates a broadcast address, but it does use an Anycast address. It uses an Anycast. In this case, it'll identify multiple destinations with the packets delivered to the closest destination. Usually something like a closest DNS server, for example. Okay, so I'm going to try to hit a couple nodes, and the closest one should hopefully get it first and respond to me first. That's what the idea behind that is. So here, we don't have broadcasting. IP version 4 used it, but IP version 6 does not. Multicasting is the same for both. Unicasting is the same for both. Anycasting is kind of unique to IP6. It's going to try to get to like the closest DNS server. So it identified these yellow nodes, and it's hitting this one first, so it's going to respond first kind of thing. That's an IP6 thing, Anycast. There are different types of IP version 6 addresses. You don't have classes like you did with with IP version 4. You don't have class ABC, but I do have different types of addresses: global unicast, link local, unique local unicast, etc. So global unicast would be a 2000 address. If I see a 2000, I'm getting somewhere. I'm getting to the internet. Link local is your FE80. This is basically inside. This is kind of be like almost like a PIPA address. I'm not getting anywhere with it, but I have that address. And if I come back here and look at my IP version 6 address on my Windows machine, I'll see it's FE80. Yeah, that's a link local. That baby's a link local. And I think I even see the same thing over here on my Linux box too. FE80. Yep, that's a link local address. So that's not going anywhere, but it is an IP version 6 address. Unique local unicast, FC00 and FD00. Unique local unicast. And then last but not least, FF00 is your multicast. So, like we had Class A, B, and C in IP version 4 addresses, you'll want to recognize the Class A, B, and C, those classes. You're also going to recognize these prefixes for IP version 6. As you see different prefixes, you'll recognize what that IP address is and what its function is for IP version 6. I do run into IP version 6 can auto-configure. It can actually create its own IP address for itself. This is similar to the IP version for a PIPA addressing. The computer can do the following. On boot up, it uses the FE80 prefix, and then the last 64 bits can be generated one of two ways. Randomly generated, or it generates from the MAC address. It uses the MAC address and uses the EIU extended unique identifier. It takes the 48 bits of the MAC address and extends that into 64 bits. That's kind of common. Step 2 is going to make sure that nobody else is using it. Step 3, it's going to ask the router, can provide configuration information, and then it'll basically use that. Okay, it'll basically use that address. Here was an example of my MacBook at one point when I connected, and I actually see here is my MAC address that I had, 881F blah blah blah, and I see 0D6B24 at the end of my MAC address. And when I connected my MacBook and got the IPv6 address, I see FE80::, and then out here at the end I do see my 6B, actually 0D6B24. There's the tail end of my MAC address being used for my IPv6 address. So this auto-configured on this MacBook, it used the tail end of my Mac to use as the tail end of my IPv6 address. Not uncommon. Not uncommon. Meanwhile, on my Windows machine, I think, I didn't think I did show it there. On the Windows machine, it does more of a random generation kind of thing. So if I take a look here and do another ipconfig on this guy, actually I'll do an ipconfig/all. That way I can see the MAC address on this and compare. That's what I wanted to do. There we go. So I look at the MAC address here, I see 283DCB. When I come down here to the IPv6, let's see what we got here. Do we have a 283DCB? No, we don't. It's doing kind of its own generic generation, if you will, which is fine. That's just what it does. But there would be my IPv6 address on my Windows machine. And there is a super quick overview of IPv6 addressing. As time goes on, we work with them more, we do more with them. But they are a little bit more simple. You don't have all those extra rules that IPv4 did. We'll come back and start talking about the next type of addressing in the next podcast.